Let T be a linear transformation from a three-dimensional vector space V1 to a two-dimensional vector space V2. Then T can be both injective and surjective, neither injective nor surjective, injective but not surjective, surjective but not injective. Means we have to tell about one on two of this linear transformation as T is a linear transformation from V1 to V2 and dimension of this V1 is 3 and dimension of this V2 is 2. If we have or anyhow we can form matrix representation of this linear transformation, or for a linear transformation there exists a matrix representation with respect to basis, then matrix representation have the size 2 by 3. Means dimension of codomain become the row and dimension of domain become the number of columns. So dimension of this matrix representation, suppose I find this matrix representation with respect to standard ordered basis, and we cannot tell about standard ordered basis whenever V1 is not specified. This is in general three-dimensional. So consider this is a basis and this is a matrix representation. For onto, it must have this matrix in each row pivot element. So maximum number of pivot element is 2 if exist. And for 1 1 each column have pivot. So there is 3 column, but maximum 2 pivot only will exist. So this linear transformation will not be 1 1. Or in other terms, you can consider there are more element here, so there are less element here. I'm not telling about which one set has more or less, but as dimension of this one is 3 and dimension of codomain is 2, it means here Li vector are 3, or Li and spanning elements are 3 and Li and spanning elements are 2. So some elements have particular image, means at least one element, at least two element will have the same image. So this linear transformation will not be 1 1. Now for onto, if we consider an element from range space, then it must have pre-image. It must have pre-image means this is a matrix representation. Suppose there is Y in this codomain, or an element B is in this codomain, then there exists X such that Ax equal to B. Means this system must have the solution, and this system must have the solution. Means there should be only one X. If there is more X exists here, it means that this system has many solution, more than one solution. It means there are two or more X that can satisfy this. It means that in terms of function, there are x1 and x2 existing such that f of x1 is y and f of x2 is y. In this case, a function will not be onto more. So this system have only unique solution whenever, sorry, not unique solution, this system will be onto whenever this matrix representation have same pivot element as number of rows. So this linear transformation can be surjective but not be injective. So option D is correct here.